Okay, Ibrahim, how many parts of motor do we have it? Yes, Ibrahim, how many parts do we have in a motor? Hello. Yes, Ibrahim.
Sorry, what's the lag again?
Motor got a permanent magnet, then an armature. Armina, what else? Permanent
Hello.
magnet. Yes. Can you hear me? Can you hear me? Hello.
So it
Hello.
has the power supply.
Okay. Yes,
Sir, I
Ibrahim.
can't understand you.
Your internet having a problem. Okay. Let's try this. Okay. First one is a permanent magnet. You have it. Then you have an armature. This one, whole assembly of that. You have that particular component, which is called as commutator. Okay. And the last but not the least one is your power supply. This one. So basically, you got one, two, three, and four component. Asjad, what about the commutator? How many components a commutator have? Asjad,
Commutator components.
main parts of the commutator.
Two.
Armina, you? We have carbon brushes and we have split ring. I've told you this is your brushes, and that part, which is this one, is called as split ring. So basically, if I ask you how many parts do you have all around for a magnet, I mean, for a motor, you will say there are five. One permanent magnet, one armature, one battery, split ring, and brushes. Split ring and a brush is combinedly called as a commutator segment. Okay. Now, Armina, you tell me, what is the job or what is the function of a permanent magnet?
So it keeps the magnet. Um,
It,
sir, it does not let the metal. Sir, I forgot.
no problem. It's a simple thing. A permanent magnet is a device which provides the permanent and a very strong magnetic field. Okay. So now I want you to just put, you already put a heading, right? Now write permanent magnet and write its function. Put a heading, functions of the components of a DC motor. Functions of the components of the DC motor. Ibrahim, what is the function of a permanent magnet?
Sir, it can't be turned on or off.
No, it's simple, a permanent magnet. So its job is to provide a strong magnetic field. That's it. It's not an electromagnet, it's a permanent magnet, north and south pole. So what is this for? Just write it down. The function of a permanent magnet, a function of a permanent magnet is to provide strong magnetic field. Strong magnetic field. Now power supply. Armina, what is the function of a power supply?
So it provides the energy to the magnets.
It provides energy to the whole working assembly, or it provides energy to the armature core along with the wire. Or you can say whole assembly of armature core, wire, and commutator segments. What is the function of armature core or armature? What is the function of armature? That box in the middle. Anyone?
To cut the magnetic field.
You can say there are two actually major functions. One function is that it actually just write it down. An iron armature along with the wire, an iron armature along with the wire is an electromagnet. As soon as the current passes through, the armature, magnetic field is produced around the armature. magnetic field is produced around the armature. After full stop, continue. Due to the magnetic field of a permanent magnet, due to the magnetic field from the permanent magnet and the armature core start rotating. Armature core start rotating, or motor effect is produced. Or motor effect is produced, which is also called as turning effect, which is also called as turning effect. Students, any problem in this? Everyone understood it? Why this is the reason for?
Yes, sir.
Good. Now, what exactly happens? Let's see that. First thing comes first. See, as soon as the current start passing, now check this out. What is the direction of the current? Upward. In that side, the direction of a current is this way, and here the direction of a current is this way, and there it comes in, right? Now I'm turning on my camera, check it out. To find out which way this particular coil will be rotating, you will have three fingers like this, right? This finger tells you the magnetic field direction. This finger tells you the current direction, and my thumb will tell you the force experienced by the armature. Now this time it's from north to south, from right to left. So I am putting my finger like this. Okay. So this finger tells you the direction of the magnetic field. And because this is the first one, so direction of a current is upward like that. So basically, if the current is like this, the direction of my thumb is in downward direction. Okay, downward direction. So basically, I've already told you, if you remember that, those sides which are at 90 degree from the magnetic field, they will be contributing in rotating that armature. This side and that side will not be contributing anything because they are parallel to the magnetic field. So on this particular side, this side, the force experienced by these two magnetic fields is in downward direction. When current comes to there, actually, now check it out. The current is here, current direction is here, and the thumb shows you the direction in the upward direction. So this one force is upward. This time the force is in downward direction. Ibrahim, which way this coil will be rotating? Clockwise or anti-clockwise?
Um, Clockwise.
Anti-clockwise, because that force will
Oh,
rotate this way and that force will rotate you this way. So technically speaking, this particular coil will be rotating in anti-clockwise direction. So that is how the force will be experienced. Okay. Now, a very interesting fact. Check this out. I'm turning off my camera. Check it out. I'm showing you the video. Now, only thing left is a commutator segment. What is the job of a commutator segment? And commutator segment job will come in a minute. Now, first of all, I'm rubbing this so that you understand. You already written what the whole theory is all about. Now, I'll show you the thing so that you understand. If you have any problem, just let me know. I'm increasing the volume. Yes, students, did you understand that?
Yes, sir. But there was no. I couldn't hear any sound of it.
Is it? You can't? Okay. Now, what exactly is happening? I'll show you again. See, once again. Now, what happened actually? I'll turn on my camera once again. See, there are two sides. Current is going this way and coming this way. What he's saying is when the current is going this way, I mean, the direction of a current is here. Now, check it out. This finger shows you the direction of the magnetic field, and the current direction is my thumb, like up, right, this way. So basically, the thumb shows you the direction of this is the actually thing is this. This is my north, and that is your this is actually the second finger is in upward direction. So force experience is in upward direction here. And when the current goes in this condition, I mean here, the current is in thatward direction, downward direction. So here the direction of a force is in right, I mean downward direction. So this coil will rotate in the clockwise direction. The easy way to understand is if the north will be here and south will be here. So that the sign will be like this. Otherwise, it's a bit difficult, but still you can simply say that the direction will be in clockwise direction. Ibrahim, any problem in this?
No.
Ibrahim, any question, Asad? Yes, Asad. Okay. Now, once this thing happened, now check it out. What will happen next? Because it will start rotating, right? When it start rotating, now they are moving it or moving it and moving. Now check it out. Can anybody tell me what happened at this position? Yes. Anyone? What will happen at this position? Yes, at this position, what will happen? At this position, remember that the point is initially when it was perpendicular to the direction of magnetic field, it contributes into the rotation, right? At this point, this is parallel to the North Pole. I mean, the magnetic field is parallel to the North Pole. Now, actually, at this position, the armature should be stopped. But the point is, it will not stop at this point due to the momentum because it has velocity already. So, from this point, that velocity will move it in the next stage. And due to the momentum, that stage will be passed. So, it will be just moving from that stage. Check it out. At this stage, the momentum will take it. Okay. So this rotation will move it due to the momentum, it will move on. So basically, now what happened? Now, my point is the question is at this point, you know what happened? Check it out one thing. At this point, let's suppose this is your A side, I mean A and B side. This is your C and D side. My question is when this rotates, right? Check it out. When that side A and B goes to this side, CD will come here and AB will come here. Arvina, what should happen if AB side will go there and CD side will come here? The direction of the force should be changed, and that armature, instead of moving clockwise now, it should move anti-clockwise. Why? Because the current direction is changed. Am I right?
Yes, sir.
But the point is, it will never happen. The direction of a current will remain in one side. Okay. So what happened actually at this point? That particular device, which is called as split ring, that also switches the current. So this actually connects with that side, and that side will be connected to that side. So what happened? It will try to make current in a unidirection. In other words, you can say that split ring make sure that the current will flow in one direction, and it makes sure that armature core will move in unidirection. So what it does, it changes the direction of a current. Ibrahim, any problem in this?
No.
So what is the function of split ring? The function of a split ring is to switch the current so that motor will rotate in one direction or unidirection. And the last thing is called the brushes. The function of brushes is it's a connection between the battery and the whole armature core, or you can say split ring. So it provide a safety or a proper connection between the whole assembly and the battery.
Sir, sir, can you repeat the split ring function?
Okay, this split ring function. Okay, split ring make sure the of the motion of a direction of the motion of a motor in unidirection by switching the current. So what is its job? Its job is to switch the current so that the motor rotates in one direction. Okay, everyone understood that, or any question?
No, sir.
So the diagrams which you have just drawn, and I send you the presentation. Now, if you read it, you will understand that they show you different positions of this split ring, that how the different position of split ring will make your job easy. Okay. Right. So that is what it is. Okay. Now motor is sorted. I mean done. Any question regarding the motor, please let me know, because I am finishing the motor. Regarding the functions, anything, equipment, parts. Any question regarding that? Motors? Ibrahim, Asjad,
No, sir.
Ibrahim, Asjad, Yamna.
Yes.
Guys, if you have any problem in this, you can go through the audio, I mean, videos. You will understand that, hopefully. Now, let's come to generators and transformers. The question is, what was the job of a motor? The job of a motor was to convert electric energy into mechanical energy. And I want you to write few lines here. The job of generator is to convert mechanical energy into electrical energy. Mechanical energy into electrical energy. The point is how. How the mechanical energy is converted into mechanical energy. I mean, electrical energy. This is important actually. A method is called as electromagnetic induction. Guys, can you just put heading electromagnetic induction? Anyone have any idea what is electromagnetic induction? No ideas? Okay, check it out. All right. Okay. Now see that. Initially, what scientists were believing that current will pass and magnetism is produced. Scientists start thinking that maybe it's possible that if there is a magnetism, electricity will produce. So what they do, they took a solenoid piece and they contact an ammeter along with it. Ammeter. They took a magnet, North Pole and South Pole. They start moving the North Pole towards the solenoid. You know what they actually checked out? What they found out? That the needle of ammeter start moving. It's a strange thing that you are bringing nearer or closer that magnet, and the value of an ammeter start coming. If the needle is moving, it means current produced. Now question is, what they did, they put the magnet here, placed it stationary. They noticed ammeter needle is not moving. But another case is, they move the magnet towards the solenoid. They see that ammeter needle is moving in one direction, let's suppose clockwise direction. Another case is, they move the magnet away from the solenoid, the ammeter needle moves in the opposite direction. Now, can anybody tell me what is the conclusion they found out from these results? Why not the needle move when the magnet is placed near to the solenoid? Can anybody put any light on this? Any ideas? Ibrahim, Asjad, Armina, what do you think?
Sir, can you repeat what you were asking?
My question is, when magnet is placed near to the solenoid, stationary, they notice that there is no current because needle is not moving. But when you continuously moving the magnet, they show there is a current shown in the ammeter. Why is that so?
Sir, because
Sir, when
Yes, yes, Ibrahim, please.
I think it's because when the magnet's like functioning, it's attracting the needle in one direction.
Yes, what about you, Armina?
Sir, when the solenoid is moving, there is electromagnetic fluctuation produced in the solenoid when the magnet is moving.
Okay.
So it shows a reading on the compass.
You both are right actually, but there is a small thing, technical word. When you place magnet here, we already understood in this chapter that magnet is actually leaving the lines, magnetic lines. We have noticed that when the magnetic lines are associated with a solenoid, in this condition, it will not affect. But when you bring the magnet nearer to that, what we notice that magnetic lines associated with the solenoid, that changes. Or you can say cutting the conductor changes. Because what happened when you bringing the magnetic field near to the solenoid, the number of lines of magnetic field cutting the conductor continuously changing with the time. As you bring it nearer and nearer to the solenoid, the rate of change of magnetic fields cutting the conductor increases, which actually produce that current. And when you move it away from it, we have seen the magnetic field cutting the conductor reduces. That is the reason this ammeter show you the reading in the opposite direction. So technically what we have find out that voltage or current produced in a solenoid is directly proportional to the rate of change of magnetic field cutting the conductor. Conductor means the solenoid. If we can't produce that rate, there will be no electricity in. There will be no electricity produced. And whatever electricity produced in the solenoid is called as induced current. That is defined by a scientist name called Faraday's law. Now put a heading Faraday's law. Then we will explain, we will write it first, and then this same effect will be used in generators. Put a heading Faraday's law. Draw a diagram and place the magnet near to the solenoid along with the ammeter, the diagram I've just drawn first. Right on the top, magnet is in stationary position. Once you copy that, let me know. Only first diagram where magnet is closed very near to the solenoid, and on top it's written stationary. Guys, did you copy that? I mean, did you draw the
Sir,
diagram?
only the first diagram.
Only the first diagram.
Yes, I've drawn it.
Ibrahim, what about you and Asjad? Have you drawn the first diagram? It is observed that when the magnet is placed near the coil along with the ammeter, there will be no deflection in the ammeter. There will be no deflection in the ammeter, which means that no current is induced. INDUCED. No current is induced in the coil. Put a small heading, reason. When the magnet is placed near the coil, when the magnet is placed, the rate of change of magnetic field lines, cutting the conductor, in the bracket write coil, so that you understand that coil is a conductor, okay? Cutting the conductor in the bracket coil does not change. So no deflection in the ammeter is shown. Students, understood this? Do you understand the statement? Rate of change, remember that. Change in the field magnetic flux linking with the conductor or a coil. Okay. Now, second case. Put a heading second case. Draw the second diagram and draw a magnet with an arrow towards the coil, as I have just drawn it.
So which diagram are you talking about?
Second diagram. You know, the one with the arrow. Draw a diagram with the same north and south pole moving towards. Just show on the top, magnet is moving towards the coil. Everyone drew it?
Sir, I've drawn it.
Okay, then write few lines. It is noticed when the magnet is moving towards the magnet, the ammeter shows deflection in one direction. Put a heading reason. As the magnet is moving towards the conductor, rate of change of magnetic field associated or cutting the conductor increases, due to which ammeter needle shows deflection in one direction. in one direction. Now draw the last diagram and put an arrow of a magnet away, just showing away from the magnet. Right on top, away from them, away from the solid, away from the moving away. Just write moving away. Draw that diagram. Wait. Put a magnet here like this and show moving away. Okay, we will leave the class here. Okay, and those who have a problem in understanding, please go through the video once again. The lectures I will upload, and inshallah, we will start from here in the next lecture. Okay.